Assalamu alaikum dear viewers, Shoaib and Dayo is here with a new lecture of the electrical machine subject, and today's lecture is the practical transformer is connected with the load. Generally in the power system there are the different types of the loads, in resistive loads, capacitive loads and the inductive loads. Our power system is inductive in nature. Mostly 90 to 95% which are the loads which are connected with our electrical power systems are inductive in nature. So they have the lagging power factor. So today's lecture of the practical transformer, when it is connected with the load impedance, we have connected with the practical this transformer with the secondary winding of the practical transformer. Again, I am going to recall the operation of the transformer concepts, that the transformer is comprises of the two windings, the primary winding and the secondary winding. The N1 shows the primary number of the turns and N2 shows the secondary number of the turns of the wire, and V1 is the supply voltage which is given to that primary winding. Hence, what happened? The transformer is draw the current from the main supply. That current is called as the no load current or the primary current. And the purpose of this current is to produce the necessary amount of the MMF, which is the primary MMF. Where the MMF is that the N1 I1. Okay, so N1 I1 means the necessary MMF is produced in the primary winding of the transformer, that may cause the production of the magnetic flux in the core of the transformer. So this phi m is links with the both windings, okay, the primary winding and the secondary winding. When this phi m is links both windings, so it can produce the EMFs in the both winding, which is the E1 is produced in the primary winding, so that will be called as the primary induced EMF, and E2 which is produced in the secondary winding, so that will be called as the secondary induced EMF. Okay, now consider the case of the transformer when it is connected with the load. Consider a practical transformer. In this case, we are going to take the winding resistances and the leakage reactances that are the negligible one in this case. Okay, so with this assumption that E2 is equal to that V2, okay, and V1 is equal to that E1, but V1 and E1 both are 180 degree out of phase to each other. Okay, in this diagram you can see this diagram, the inductive load is connected with the secondary side. So this is the ZL impedance, inductive load which is connected with the secondary winding of the transformer, which causes the secondary current I2 that lags the voltage V2 by phi 2. What happened? When we are taking the consider the practical transformer case, okay, then the phi 2 is produced that links with that secondary winding is that the secondary flux which is induced in that secondary winding of the transformer. So it can produce your I2 is produced because the load is connected with the secondary winding of the transformer. So the total primary current I1 meet the two requirements, means when the transformer is energized from the supply, your AC supply, it draws the I1 current from the supply. It can meet the two requirements. The first is that it must supply the no load current to meet the iron losses or the core losses in the transformer and to provide the flux in the core. Means when the transformer is energized from the AC supply, what happens? Your EMF is induced in the windings in the primary and the secondary winding because of the magnetic flux which is produced in the transformer, and that magnetic flux which is produced in the transformer is because of the primary current which is to be drawn from the main supply. So that will be called as the no load current, that to meet the iron losses or core losses in the transformer. Second is that it must supply a current I2 dash to counteract the demagnetizing effect of the secondary current I2. What happened? When the load is connected with the secondary winding of the transformer, I2 current is produced because the load current which is flowing from the secondary winding of the transformer, that can be because of the connecting the ZL impedance or the inductive load with the transformer. Now to counteract, neutralize this demagnetizing effect which is produced by that the I2 current which is flowing in the transformer. So 180 degree out of phase, there is another current which is to be drawn from the supply to counteract the demagnetizing effect of that your transformer secondary current. The I2 dash will be drawn from the additional current from the primary winding, so that it can utilize the effect of this I2. Okay, and then what happened, you can analyze this expression, from this mathematical expression, is that N1 I2 dash, this I2 dash is the counterbalancing current which is to be additionally drawn from the primary side to neutralize the demagnetizing effect of that I2 current which is produced due to the load which is connected with the transformer. And here N2 is N2 I2. So if we are getting the value of that I2 dash over here, so N2 divided by N1 is equal to multiplied by I2. So where transformation ratio N2 divided by N1 is equal to the K. So put the value of the K over here. So it will be the I2. Means I2 dash is that counterbalancing current which is to be produced by the additionally current which is to be drawn from the supply to neutralize this effect of the I2 which is produced in that secondary winding of the transformer. So total primary current I1 is the phasor sum of the I2 dash counterbalancing current and your I0. Okay, so I1 is the sum of the no load current and plus your counterbalancing current I2 dash. Okay, so if we have considered the value here, the K is equal to the 1, so I2 dash is 180 degree out of phase to that I2. So let's discuss the phasor diagram of the practical transformer when it is connected with the load. So you can see the phasor relationship is drawn between this V1, okay, here E1 is in phase and E2 is in phase to that V2. Now this is the magnetic flux which is to be produced by the transformer because of the I1 current. Okay, here I1 current is the sum of the I0, phasor sum of the I0 plus I2 dash will be the I1. And then your phi m, which is the magnetic flux. So here this I1 current is lags behind the V1 applied voltage to the transformer. Second thing is that your I2 current which is produced in the secondary winding of the transformer, because the impedance inductive load which is connected with the transformer, so this current is to be produced and this current is lags behind the secondary induced EMF or the voltage which is the V2. Okay, now as you can see, this I2 dash and this I2 both are 180 degree out of phase to each other, because when this current is produced to neutralize this effect of that I2 over here which is the produced in the secondary winding of the transformer, so demagnetizing effect can be neutralized by this I2 dash, that is equal to that 180 degree to out of phase to each other. Okay, so phasor diagram shows when load is connected with the secondary winding of the transformer. Okay, already this description has been explained by me, and now again I am going to repeat these all the points to verify this phasor diagram. Okay, both E1 and E2 lag behind the mutual flux 90 degree. Okay, you can see this E1 and the E2 both are lag behind this phi m by the 90 degree. Okay. The current I2 dash, okay, this current I2 dash represents the primary current to neutralize the demagnetizing effect of the secondary current I2. When secondary current I2 is flowing from the secondary winding of the transformer to neutralize this demagnetizing effect of that which is produced in the transformer, so the flux, main flux is what happened when the additional current, when the secondary side load current is flowing from the transformer, your main flux which is produced in the transformer core is reduced. So what happened, to maintain its constant flux in the core of the transformer, to maintain its magnetism, we have to neutralize the demagnetizing effect of that I2. So how you can demagnetize it? by additionally draw the primary current from the supply to counterbalance the I2 current over here. So this one is that I2 dash and I2 both are 180 degree out of phase to each other. Okay, now I2 dash is equal to Ki2 is anti-phase with that I2. Okay, I0 is the no load current of the transformer. So this I0 is the no load current of the transformer. So this is the phasor sum, means your I1 is equal to I2 dash, okay, plus I0. So this primary current is the phasor sum of that counterbalancing current and plus I0. So if the K transformation ratio is equal to the 1, obviously the primary phasors are equal to that secondary phasor. So primary power factor is that cosine phi 1, okay, secondary power factor is that cosine phi 2, primary input power is that V1 I1 cosine phi 1, and secondary output power is that V2 I2 cosine phi 2. So this was the lecture of that practical transformer when it is connected with the load, in which we have discussed the operation of the transformer, practical transformer, when it is connected with the load, and also we have discussed some components which are produced in the practical operation of the transformer with the help of the phasor diagram and with the help of the circuit diagram. Dear viewers, this was the lecture regarding the practical transformer operation with the loaded condition and inductive load which was connected with that transformer. I hope that you have understood today's lecture, and at the last, please don't forget to subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical engineering area. Thank you.